Okay, so we ended Unit 2, or the stuff before the test, with graphing systems of equations, where we had two lines on the same coordinate plane. Today we're going to be talking about systems of linear inequality. So instead of having the equal sign for an equation, we have inequality symbols. So the inequality symbols we're going to be working with. We have less than, greater than, and then less than or equal to, greater than or equal to. So it just depends on whatever way this symbol is facing. So the small end is always pointing towards the smaller number, the smaller value, and it's opening up towards the bigger value. So this symbol is the less than, because whatever's over here is less than this. And when we start graphing these inequalities, less than we use, and when we start doing domain and range too, it's going to have open dots for a point. So instead of a filled in dot, it'll be an open dot. And we used dashed lines. Okay, and then below it, the sign is just flipped the other way, and this is the greater than symbol, because whatever's to the left is greater than whatever's to the right. And since it's not or equal to, it's just greater than, we also use open dots and dashed lines. Okay, so those are the less than or greater than. Then if we scooch over, the symbols look similar. The only difference is there's this line underneath, and this means or equal to. So now a value can be less than or equal to something else. So less than or equal to. And for this, we would have closed dots and solid lines. Yeah. And then same idea with less than or equal to. The sign is just flipped. Or sorry, greater than or equal to. Greater than or equal to. We have closed dots and solid lines. So a way to remember it, the solid line goes with the or equal to because it has a solid line underneath the symbol. So line here, solid line here. Okay, so or equal to's get the solid lines, just greater than or just less than get the dashed lines. All right. So when we are graphing inequalities, you first need to rearrange the inequality, just like we would if we were trying to graph an equation. So using our opposite operations. In order to get y by itself. Okay, we want y by itself, not x by itself, because in order to graph, like using slope-intercept form, that needs to have y equals. Okay. And one important thing as you're doing this, if you have to multiply or divide by a negative number in order to get y by itself, you have to flip the inequality sign. Meaning if it was a less than or equal to, you'd have to flip it to be a greater than or equal to. You only have to do that if you're multiplying or dividing by a negative, adding or subtracting. You don't have to change the sign at all. the inequality sign. So for example, if we had this inequality negative 2y is, and this is less than or equal to, so negative 2y is less than or equal to 4x plus 8. We want to try to get y by itself, so what's preventing that from happening right now is it's being multiplied by the negative 2. So to get that y by itself, we would divide by a negative 2. But since we're dividing by a negative, we have to flip the inequality sign. So we'd have y, and then instead of less than or equal to, we flip it. So now it'd be greater than or equal to. And then we do our division. So it would be negative 2x and then minus 4. So we flip the signs whenever you have to divide by a negative number or multiply by a negative number. Again, adding and subtracting is fine. You can just add stuff to either side of the inequality, and you don't have to change any of the inequality signs, just if you're or multiplying or dividing by a negative. Okay, so once you have y by itself on one side of your inequality, preferably the left side would make it a little easier. You're going to graph the line as you would if it had an equal sign. Just pretend it's a regular line that I'm asking you to graph. You can find your y-intercept and then use the slope, rise over run, to get a couple more points. And then when you are connecting your dots, remember if it's just less than or just greater than, you use a dashed line to connect your dots. So it just depends. If it's greater than or equal to or less than or equal to, you use a solid line. Okay, so let's do that part, the graphing. So we have our inequality that we solved for. Y is greater than or equal to negative 2x minus 4. So we first just graph it. We find our points just like if it was y equals negative 2x minus 4. So our negative 4 here is our y-intercept at the point 0, negative 4. And then our slope is negative 2 or negative 2 over 1. That means we'll go down 2 and right 1. So down 2, right 1, down 2, right 1. I can go the other way by doing the opposite, so up 2, left 1. Okay, and then since it's the inequality sign is greater than or equal to, we have that solid line underneath. This means we would connect our dots with a solid line. So you connect your dots, solid line, and when we are doing inequalities, it's very important that you have your line go all the way through the coordinate plane. So a line goes all the way through because of the next part here. You need to have it cross it entirely and have the arrows going out the sides. Because the next thing we do, since it's an inequality, we get to do some coloring. We get to do some shading. So the direction of the line you're going to shade is either going to be above the line or below the line, and that just depends on the inequality sign. So if we have a less than sign or a less than or equal to sign, so one of these or one of these, so it's less than, you would shade below the line. And then if it's greater than or equal to, you shade above the line. Okay, so less than, below, greater than, above. So if you look at ours, inequality that we graphed, based on our inequality sign here, would we be shading above or below that line? Above, because its y is greater than or equal to. So it's a solid line and it's greater than or equal to, oops, if I could spell, or equal, so we shade above. So you just take your line and above it, and you shade this whole area above the line. This is why it's important to have your line go all the way through, so you know how far to do your shading. So make sure that your shading goes right up to your line, but not past it. Okay. All right. Questions so far? Okay. So on the next page, we'll do one more together, and then I'll let you guys try. So letter A here, remember our first thing we need to do is get y by itself. And usually we like to have y on the left side just because it's easier than to read the inequality and see what side of the line you have to shade on. So right now our y is on the right side of the inequality, but if we move it over, we would get the y on the left side, and we also would get rid of that negative situation, which means we won't have to worry about flipping the sign. So if we take our inequality, let's move our y term over. So right now it's a negative or minus 2y, so we would add 2y to both sides. And again, adding and subtracting, you don't have to worry about changing the inequality sign. So now we have 2y plus x is less than or equal to 4. Now to get y by itself, we deal with any addition or subtraction first. We subtract x from both sides. So we'd have 2y is less than or equal to 4 minus x. And then finally, to get y by itself, we can divide by 2. Since it's a positive 2, we don't have to flip the inequality sign. We can just divide every term by 2. So we'll have y is less than or equal to 2 minus, and x divided by 2, that's like a 1/2 x. If you want to keep the number out in front so it's more obvious as to what the slope is, that's fine, or you can keep it as minus x over 2. That works also. Okay, so now we need to graph our line. So our y-intercept is the value that doesn't have the x attached to it. So that's the 0.02. So 0, 2. And then our slope is the number in front of x, which is a negative 1/2. So we go down 1 and right 2. So we can do down 1, right 2, down 1. So remember, slope is a rise over run, change in y over change in x. And we want our points here that we're finding to go all the way through our coordinate plane. Okay, and then when I connect my dots, will I use a solid line or a dashed line? Solid, yes, because it's less than or equal to. So solid line, go all the way through the coordinate plane. And now since it's an inequality, that involves the shading, so will I shade above my line or below my line? Below, because its y is less than or equal to. So again, you go right up to your line, but not past it, and everything below. Okay. So I would like you guys to try B and C. So remember, get y by itself first. If you ever have to divide or multiply by a negative, you have to flip the inequality sign. And then remember when you use dashed lines or solid lines. So go ahead and try B and C, and I'll be walking around if you have questions. Okay, so letter B, in order to get y by itself, you should have divided by -2. Everything gets divided by -2. And then since we divided by a negative number, that means we have to flip the inequality sign. So now we'll have y is greater than instead of less than, because we divided by a negative. Then we do our division, so -2 divided by -2 is a positive 1x, and then -4 divided by -2 is a positive 2. And so then we graphed it. Our y-intercept is 2, and our slope is 1, so up 1, right 1. And then solid or dashed line for this one? Dashed. Okay. So with the dashed lines, it is not going to be obvious on these coordinate planes that you have a dashed line, especially when you start shading. So please help me out and help yourself out so you can get the point. If you draw a dashed line, can you just draw a little arrow and write, hey, it's a dashed? Or just write dashed somewhere so I know you know that's a dashed line, because sometimes it's going to be difficult for me to see on the coordinate plane with all the shading if it's actually a dashed line. So help yourself and help me help you. Okay. Yeah, so it should be a dashed line, and then do we shade above or below? Above, because it's greater than. So again, all the shading right up to the line, but not past it. Okay, any questions there? Okay. Letter C, y was already by itself. So you just had to go right to graphing. So our y-intercept was -5, and then the slope is 1/2. So that's up 1, right 2. Up 1, right 2. Or down 1, left 2. And then solid or dashed line for this one? Dashed. So again, just label it as dashed for me, just to help me out here. And then shade above or below? Above. So right up to the line, but not past it. Okay, so coloring in the lines is important here, at least on the line side. You can't go past your line that you graphed. Okay, so that's how you graph one inequality on a coordinate plane. However, we are focused on systems of inequalities. So a system of inequalities is when you graph two or more, we're just going to be focusing on two, inequalities with their shading. On the same coordinate plane. Okay, so over here on this coordinate plane, I'm just going to sketch an example. So I don't have an equation or any inequalities that we're looking at, but just so you can get an idea as to what this would look like. So if you have one line, and then let's say this one was a less than or equal to, so you'd shade below. So that's your first inequality. But then with a system of inequalities, we have two inequalities or more. So if we had another one, and let's say this one is greater than or equal to, so you shade above that line. Now a solution to a system of inequalities, similar to the system of equations, right? The system of equations, our solution is where the two lines intersected, that point. Here, the solution to a system of inequalities is where the shading overlaps for those. So a solution to a system is where the shading overlaps. So in this example that I drew right here, the two shadings overlap in this little triangle piece here. So this whole shaded region, right in between the two lines, that whole area here is the solution. Okay, so a solution to a system of inequalities is not just a point, it's a whole area. Okay, so let's do some examples of systems of inequalities. All right, so we still need to get y by itself first before we can do any of the graphing. So in our first inequality here, in order to get y by itself, we could subtract 2x from both sides. So then we'd have negative y is greater than or equal to negative 2x minus 3. And then in order to get y by itself, we have to divide by a negative 1. So everything gets divided by a negative 1, and that means we have to flip the sign. So now we have y is less than or equal to 2x plus 3. Okay, and our second inequality, y is already by itself, so we're good there. So we start with our first one. The y-intercept is 3, so the point 0, 3. And then our slope is 2, so that means we go up 2, right 1. And then it's less than or equal to, so that means we'll use a solid line. Then do I shade above or below? Above or below for this? Below, because it's y is less than or equal to. So when we're doing a system, it's helpful if you shade lightly first, and then you can darken the solution where they overlap. So just lightly shade below this line, just so you know where that shading is at. If you have different colored pens or different colored pencils, I do have colored pencils over on that shelf there, that can also be helpful for this too. And you can clearly see the two different inequalities and their shading. So just lightly shade for right now. Then if we do our second one, so I'll use red for my second one. We have a y-intercept of 1 to the point 0, 1. And then we have a slope of 1/2. So we go up 1, right 2. Or down 1, left 2. Okay, and then will I use a solid or a dashed line? Solid, because it's greater than or equal to. And then do I shade above or below? Above. So at this point you have two options. You can do the whole shading for that line, pretending like your other line isn't there, or you can look and the solution will just be wherever you already shaded the first line that's above your second line, because we shaded above. So you can shade your whole thing if you want, like above that whole line. And then see, oh, here's a little sliver where they all intersect, where that shading intersects. And so that is your solution. Again, when you're doing your solution, you have to make it very obvious as to what your solution is. So shade it much darker, do a different color, draw an arrow that says solution. Okay, make it very clear. If it's just a little bit darker, it's not going to be obvious. So make it, you want to erase the other shading so it's not in the way, that's fine. But just make it clear as to where your solution is. Okay. Can you guys try letter B? So get y by itself. Remember, flip the inequality sign if you ever have to divide by a negative. So go ahead and try letter B right now, graphing and solving the system of inequalities. Okay, so I have up here the solution for B, so it should have been the top triangle part. Make sure that you remembered to flip the inequality sign for the first one when you had to divide by a negative to get y by itself. And then again, please help me out and label your dashed lines as dashed, just because once we start doing all the shading, it's going to be very difficult to just see it, so make it obvious. And then the shaded part that your solution is, again, labeling a solution wouldn't hurt. So either make it way darker, make it a different color, or label a solution, do something to make it obvious. Okay? Any questions? So this is just coloring, really. Graphing lines plus coloring. Okay, so a couple special cases here. Example 3, so 3a, y is greater than -2. So when we graph lines, remember we pretend like it's equals just for graphing purposes. So this was the equation y equals -2, what would that line look like? If it's just y equals a number. Yeah, it's just a horizontal line. So at the value of -2, it's going to be a horizontal line. Will it be a solid line or a dashed line? Dashed. So a dashed horizontal line going through y equals -2. Again, label it dashed. And then its y is greater than -2, so that means you will shade above. Again, it's above this dashed line, not the x-axis. I don't care about the axis at all. So you go right up to your dashed line, but not past it. And up. And then our second one, x is less than 1. If this was just the equation x equals 1, what would that line look like? Yeah, a vertical line at x equals 1. So you go to the x value of 1. It's right here. And as a vertical line, will it be solid or dashed? Dashed. You can label it dashed. Help me out. And now, vertical lines, there's not an above or below with a vertical line. However, if we want the x values to be less than this line, less than 1, would we shade to the left or to the right? Left, right? Because this is these are our negative values. They get smaller as you go to the left. This is our less than. So that's only when there's just an x and there's no y is when you got to think about it in terms of left and right. So again, you go right up to the dashed line, not the y-axis, up to the dashed line, and to the left. And where they overlap is this top left corner here. Again, go right up to the dashed lines and color inside your lines. Okay, so this is our solution. Okay, our next one, letter B. So y is already by itself for both of them, which is good. So then we can just go right to graphing. So I'll have my first one be red, my second one will be blue. So for the first one, the y-intercept is a -1. And then the slope is 2. So up 2, right 1, up 2, right 1. And its y is greater than, not or equal to, so we get a dashed line. Then since it's greater than, we shade above. Okay, and then my second one, I'll do in blue. We have a y-intercept of -5. And a slope of 2 again, so up 2, right 1. And this one's also less than, so a dashed line for this one too. And then less than we shade below. And so do these two shaded regions overlap anywhere? Do they? No, and that's because these two lines are parallel, which means they're never going to intersect, first of all, and then they're shaded on opposite sides of the line. One is greater than, one is less than. So these two regions will never intersect. There'll always be that neutral zone between those two lines. So when there's no overlap like that, this is a no solution, because there's no overlap. Letter C. So my first one I'll do in red. We have a y-intercept of 2 and a slope of 1/2. So that's up 1, right 2. And it's less than or equal to, so it has that line underneath, so we get a solid line. And then less than or equal to, we shade below. And then our second one, I'll do in blue. There is no y-intercept, which means it's at the origin, which means it's 0. And so they'll have the same slope of 1/2, so up 1, right 2. And less than or equal to, so solid line. And less than. So here it just turns out that they're almost exactly the same. There's just that little bit of shading from the first one in between the two lines that doesn't count, but everything else below this blue line would be the solution. Do you guys have any questions?